Well, welcome to this special episode of The Dental Guys at the Academy of Osseointegration 2024 annual meeting. I'm Wes, the Dental Guy.
And I'm John, the Dental Guy. And if you've been watching some of the things we've released over the last bit here, you'll be excited to kind of say, well, what's coming next? You know, because there's been so much great interaction that we've had, both from clinicians, researchers, industry, you know, kind of a little bit of everything. It's challenged the way we think about things. We've heard about new products, new innovations, things that have just, I think, are going to be game changers.
The thing that we've always looked for is the conversation with the people that are the most passionate about what they believe in their product. Maybe over the years as podcasters, we've looked for the innovators in the fields, people that are thinking outside of the box, people that aren't afraid to question what has just been the standard, John.
Right.
And sometimes it takes that. Yesterday we heard someone say, sometimes you just have to remove something that you've been doing for so long to move forward.
Yeah.
This year's theme is going beyond the boundaries. And there's no greater company in the last, say, 5 years that I know of that has really pressed that boundary. Some interesting innovations from our special guest today, which is Graham Blackbeard from Southern Implants. So welcome to the show, Graham.
Thank you very much, John and Wesley. A great pleasure to be here with you.
Yeah, we're excited to speak with you. We've heard you speak in the past, and we've gotten to know you a bit. And for those who have not heard you speak, you always come with a great deal of passion and believe in sort of what is possible. And I think we've seen that reflected in sort of some of the things that have been developed over the years. Give us a little bit about your background, maybe the background of the company, where it came from. Just start with that. Tell us a little bit about that.
Gosh, okay. Well, we started off 36 years ago, so it's been quite a long journey, and it was the same time that Richard Lazara and Keith Beattie started 3i. So we were very good friends, and we collaborated quite a bit in the beginning. I'd actually been making heart valves at the University of Utah, where it was the artificial heart program, and I was making heart valves with titanium housings. And two professors of prosthodontics approached me and said, can you make us some abutments? And I said, what's an abutment? Knew nothing about dentistry at all. And then ended up sitting with prosthodontic residents, learning all about dentistry and working out what we needed to do. So ended up putting the first implants into an Austrian who happened to be living in South Africa at the time. So I'd moved back from the University of Utah back to South Africa at that time. I'd learned how to ski, and that was really mission accomplished.
That's good. So by saying that, you know, for the listeners who don't know, you're an engineer by trade, correct? That's your
right.
training.
Yep.
And so you were asked to take the knowledge that you had and apply it to dentistry. And obviously over that time, a company was sort of born through that. And obviously we've spoken to a couple of folks over the years who are engineers in the dental world. And you know, one of the things I want to talk a little bit about is implant manufacturing, because obviously it's changed tremendously over that many years. How much better are we now at implant manufacturing, milling, things like that, than we were, say, when you began?
Yeah, there's been a lot of change. The first change is in the materials, titanium being a fairly modern material. None was used in the Second World War. It's now extensively used. The Boeing 787 is the commercial airliner with the majority of titanium, or the biggest part of titanium of any commercial aircraft. Fighter jets, lots of it. So the development of titanium is very critical, and the titanium that we use today to make implants is nearly double the strength. The most recent batch, we had a tensile strength of 993 megapascals. Now, when we started off, we were battling to even get to 500. So the materials have got better, which means we can make smaller implants, more bone, less titanium. And so there's always that ability. So you've got to be on the forefront of looking at where the developments come. So the coaxial implant, which everybody knows us for, which we did back in 2002, when Dale Howes, the prosthodontist, came to us and said, can you make an implant like this? I'd fortunately just been at a machine show in Switzerland and saw a new cutter. And that, because you could spin it at 8,000 RPM, you could mill a thread from the bottom up. So we then discovered that actually this concept had been thought of by two Germans, Schilly and Hartmann. They'd taken the patent out on it. But nobody could make it at the time that they'd conceived it. So they'd almost given up. So we went and bought the patent from them. They were delighted because the technology had now got there and we could make coaxial implants, which nobody else was able to do until then. So you've got to be right on the forefront of looking at machining technology and being able to do that. I think one of the biggest problems with things now is that people want to do it without any humans involved and run the machines through the night. Absolutely the worst thing you could do, because of course the same problems exist. Tools get blunt. So if you really want to make a high quality product, we only run the factories 8 hours a day.
Yeah, it's interesting you mentioned about these things, because we could go out here on the show floor and probably find somewhere we could buy a milling machine, or someone that knows of someone we could buy and have it sitting in our office tomorrow. And a lot of things that we do here, sometimes we rely on other people's ideas, and then because of a predicate or something like that, we can just start milling these parts and pieces. It takes more than that. It takes more understanding. Right down to some of the things like what floor the milling machine is setting on, how thick is the concrete. I want you to speak to just the intricacies of what it takes to give high quality OEM parts to the doctor.
Yeah. So the first thing that we realized is that you need to take full control of items. So often in business school they tell you, subcontract things out, use these people, etc. But probably because I'm a little bit like Elon Musk. We both come from the same town, of course. We want to bring everything in-house because then you can control it better. So absolutely, design of the machines, although we use people who build machines, but we specify what we want. You keep all the parts, you do all the maintenance yourself, you rebuild them once a year. So you just absolutely have to get involved. All the cutting tools, we actually have tool makers, we grind them ourselves, we don't buy from tooling companies because you want to have that absolute nth degree control, and especially important with dental implants, where we're talking about machine surfaces that we want to integrate for a hybrid surface. And a lot of people miss that sort of fine detail of what you need to do there. So often the machines that are available off the shelf just aren't quite right if you really want to go to the nth degree and get these things to really be the best they possibly can.
Yes.
So yes, tool making has to be in-house, in my view, in order to be able to optimize that. And now we're doing a lot of work on abutment surfaces. And a lot of the research goes back to the 1990s with Mark Querinen, etc. And it's an area that needs a lot more development. So there's always just so much that can be done to make better products.
So let's talk about, you mentioned, hybrid surfaces, for instance, because when we look at some of the products that you've developed, we see, well, let me go back to when we spoke, this is years ago, with Dennis Tarnow about roughness and what was the right roughness, the amount of roughness that would have, that would attract bone, but also the potential of a surface that might be more cleansable in the event that it was exposed. I know you've done a lot of work on that, and talk about that and kind of how that comes back to the consistency of the manufacturing process as well.
Yeah. So one of the things with making biomedical devices is that complexity of manufacture gets you down because it's difficult to control. So you've always got to be able to control these things. So I've worked quite a lot with Anne Wennerberg and Thomas Albrechtsen. Thomas is here, so it was lovely seeing him again. And some of the work that they did back with Soskalny and looking at that. So, yes, I've got some philosophies and beliefs about that. I think a lot of the surfaces, people inadvertently don't realize that when you treat it with acid, you change the crystal structure in the outer layers and make it more corrosive. So we had a lovely lecture yesterday on,
we saw
on metallosis, etc. The part that was missing there was the fact that in the surface preparation, you vary the ability of that surface to corrode, inadvertently not knowing that if you've done this, what it does. So you've got to do a lot more testing of items to look at their inertness. And yes, if there's no biofilm around, maybe it doesn't matter that much. But of course, we know people have biofilms in their mouths. So we've got to look into that in a lot of detail. So I don't believe in acid treatment. A lot of the people tell you, oh, we're doing it to add fluoride. That's normally nonsense. They're doing it to try and, because it's an easier way to clean it. So if you acid do it, you can get rid of the stuff more easily. So the harder route is to clean the surface without acid. And then you leave that oxide layer intact, and then you make the implant far more inert. We work with the NPL laboratory in London. They've done a lot of work for the orthopedic industry, and that is all about inertness and trying to get the titanium more inert.
Your company's been very unique in that they've adopted some of the tried and true platforms across industry and utilize those to help clinicians really get the implant that they want for their patients. And in doing so, you've had to adopt a high level, like you've been describing, of milling, and connections have to be just right. They have to be a certain standard. Sounds like a very high standard. But yet what that opens you up to is the ability for that platform to be able to be, well, I can go off the shelf over here and I don't have to get a southern part. I can get this part. And I think there's a lot of that going on. And I want to hear from you about why we should choose OEM parts for our patient's implants.
So the first thing is on connections. I think it's irresponsible for a small company to do a unique connection. And the reason is that that patient could be 40 years from now. If you put an implant into an 18-year-old, they're going to live to over 100. And they're going to need to be able to get parts. You cannot really guarantee that the company will still exist. And being a collector of old cars, I know how important it is to be able to have spares backup. So I believe fully that you should be able to back it up forever. But the problem is, of course, if the company gets taken over or whatever might happen, which we have no intention of allowing that to happen, but, you know, things can go wrong. So I think that there are enough connections out there. So what we've always done is look for good connections that you can then possibly improve with tolerances and just make it that much better, but leaving it compatible. Yes, it does open you up that people will use third-party OEM parts or whatever the case might be. But I think there we've just got to show, and which we can under SEM, etc., that the original parts do fit better because you know exactly what you want there. And there lots of the lower cost parts, they tumble them to remove the burrs, which puts little radiuses on, which become places where the bacteria are going to go and sit in the crevice. So it's always better to use the original manufacturer's part. But in case of absolute need, people move around the world. And if it's a compatible connection and all of a sudden the ladies in New Zealand on the South Island and something breaks, then it's always better that there is that ability to be able to go and at least get it running again.
It's wonderful. John, you and I know two of our favorite clinicians are Stephen Chu and Dennis Tarnow. And I really appreciate what you guys have done working with clinicians. You mentioned Alberkinson, and your relationship with him, and him working with Branimark all these years, and now you're working with some very high-level clinicians as well, in Dennis Tarnow and Stephen Chu. And as I want you to talk about the importance of that from a company standpoint, and what that's allowed you to do, because there's some very innovative products that come from being a nimble company. And one of the frustrations that John and I had in our implant career over the last 20 years is larger companies, yeah, they do offer the ability to research product, but it seems like they don't innovate at a certain rate that is, maybe applicable to some of the things that we're seeing clinically. Like, hey, I'm seeing this. Can we make a small change here to improve this for our patient care? How is working with top clinicians like Dennis and Stephen really been a game changer for you?
Yeah, I think the first thing there is that we believe that this is a team event to be able to do the right things. So the top clinicians are an integral part of the team. And we see them as being our ears and eyes in the clinical situation. So our job as engineers is really to interpret what they're wanting. And it's just a wonderful opportunity when you get to know people like that. So the AO is a place where I really got to know Dennis. And it was always in the poster sessions. I would always be hanging around in the poster sessions because that's where often the best new stuff is happening. And Dennis would be there with his residents, and we'd interact and have discussions. So that's really how I got to know Dennis, by doing that. Sitting and having dinner with people, you pull out a serviette and you say, well, what is the issue? And in the case of the implant that we developed with them, it was a case of, your Max implant is a wonderful implant for stability in molars, but we need something for anterior extraction sockets. So they taught me about what their challenges were, what needed to be done, and it was really just a question of saying, hang on, what about this? And together we obviously came up with the design of the inverter. Then the question is, you don't want to lose their enthusiasm. So you've got to be quick. And having everything in-house, tool making, etc., we soon were able to have implants on there. We also do all our regulatory in-house. So just, get the guys onto it, get the 510K. Let's get these things happening quickly. And of course they have wonderful relationships with people like Ron Nevins, etc. And we said, okay, we need a dog study. Who do you go to? You go to the top people. So yes, I must say 36 years ago I didn't have those contacts.
Sure.
And it's just wonderful to have these friends around, and then you mustn't let them down. And if you're going to do something, you've got to put your whole effort and weight behind it. To make it happen.
Yes, and I think that's what we're seeing, with many times there's this focus on, we have a product, so let's adapt that to the clinical situation, versus we have these clinical situations, so let's make a product for that. And that's just two completely different ways of thinking. And I think that, obviously you've embraced the latter, that we need to look at what we're learning in the literature, what we're seeing happening clinically, and then let's see if we can idealize the product for that.
Yeah, and that's the other thing. You have to keep a good eye out on the literature. I used to be able to read a lot of journals. Fortunately, I now have wonderful people who do it. And they can feed the information through so that you can keep on top of that. But the other factor is dealing with, even things that are probably commercially not that interesting for most, the cancer patients. So we love working with the centres like Liverpool in the UK with Chris Butterworth, etc., where they have unbelievably important needs because it's life-changing for those patients. And to work with there, you often then, because you've got very compromised situations, they've been radiated, etc. So there you don't need just regular implants. You need implants with a plus on it because they've got frail, soft tissues, everything, is bad. So you've really got amazing challenges. But yes, they're obviously not that many, and most companies don't find that too interesting. But it's a good place to learn a whole lot about things that you can then put into regular dental.
Yeah, and that's just passion, right? And that's the thing that comes through clearly, is that this is about, it's a labor of love rather than just simply looking at a profit situation always. And I think that's what we spoke about last night as we were talking to some of your friends about, that in the end, what we do as human beings matters. And I think that, you clearly feel that way, that, it's we're here to help people. In the end, it's about people. I want to go back to one thing you mentioned about abutment technology, because I know up till now, mostly the focus in your company has been on the implant manufacturing side. Right. And you mentioned just briefly as we were talking the other day about what some of the things you're thinking about with abutments, and potentially even maybe with what we could do to get soft tissue adherence or attachment potentially, or ways that we can make our stability better. Talk about what you're thinking about with that. What might be coming down the line with that?
Yeah, so abutments often have slightly different requirements when you look at the shapes and how they are. So sometimes the alloys of titanium are better. So the first thing is we're trying to get away from the vanadium-based alloys, the grade 23s. And there are fortunately some lovely new developments in that area. So we got quite a lot going on in looking at replacements of even prosthetic screws, etc. The second factor is plasma vapor deposition coatings, where you can put a coating onto an abutment that makes it much harder, which means that the oral hygienist can scale it without scratching it. Because, a new abutment is lovely, but after a few years in the patient's mouth and with a lot of scaling, it looks like a dog's breakfast, and has all the plaque accumulating to it, etc. So one can do that by putting one of these harder coatings, titanium nitride, but there's also another one that we're working with, which I won't talk about now because everybody will want it. We've got to get there first. So those are really good. In terms of surface roughness of abutments, we picked up that with these angled abutments, that often the surface isn't like a normal turned surface, which has some very good attachment to it, and those are the ones that really cause the problems and have a lot of calculus and plaque accumulating to them, etc. So there you can just improve your machining technology. So instead of taking 0.6 micron bites, you take 0.3 and you can improve it. But you've also got to put new tools in the machine very regularly. These
aren't things that you see by, A and B looking at it under even just, your loops. You have to look under SEM to be able to see this. And you were describing it like steps.
Right.
Almost like rice fields up a bank, and like hard edges. And really changing milling strategies and actually using something that's more precise at turning these angles as we look at abutment contours. It's really important.
So that's the fun of it, is to look at machining developments and to see how you can actually make these things better. But yes, very difficult to see. So you have to have SEMs and that sort of thing.
Well, that's the goal, though, I think we've had, and companies have kind of attempted this, I think, in different ways to try to get attachment potentially to an abutment. It's kind of one of these holy grail things I think people have tried to get, and even with multiple disconnections. And so, again, I think if I understand, normally, again, when you're turning parts, you can develop this circumferential grooves that are very, very precise. But when you're trying to go around a corner with that, you're having to mill. You're not turning anymore. So that's the difference. Is you've got to know how that when you turn that corner on those angled abutments, that's when it's the challenging part.
Yeah. So the bottom line is, if you can put the angle into the implant and rather use straight abutments, they're much better.
Right.
Because of machining technology. So the angled abutments look sexy and all the rest, but they're generally quite badly made because of what technology is.
Yeah, you're using a lathe versus a mill. And, if you're listening to this right now and you're thinking, what's a lathe? Well, if you've been to Dad's wood shop and you're going to turn the legs on a table, you're going to use some type of lathe, a circumferential, and you can be very precise with that. You can take sandpaper and really fine-tune that surface to where it just is beautiful, right down to the finish and the glaze that you put on that, and it can look like something that'll last a long time. But then when you go to a mill, things change. Yeah. I don't think people think about like all that goes into really manufacturing. And that's why engineering and someone that's at the top of an organization like Southern Implants that is really truly passionate about some of these small steps, it's all of the things stacking together that really give you this quality product.
Well, how is it that, I think when we talk about all of this, right, so we know we've figured out over the years, I remember back hearing Dennis talk about how the early Bronnemark implants, the turning, they were turned, and yet, we've somehow stumbled almost upon the correct roughness, but in some ways it wasn't super precise because we didn't have the great technology. Now we're at a point where I think some of the struggle, we've been hearing it through this meeting, is what happens when these surfaces get exposed. And so as a company, obviously you're thinking, okay, in the ideal situation, with the ideal placements, the way we want it, we're going to get potentially amazing bone deposition. But if that surface gets exposed, tell us about how you're thinking differently about that, knowing that not everything is perfect and sometimes things do go wrong. And how do you kind of account for that in your manufacturing?
Yeah, well, Adet Bahat, gives lovely lectures on how the skeleton remodels. So to say that your implant surface will never get exposed is really a myth. It's going to happen in some patients because the remodeling is very patient dependent. So that's the first thing. The second thing is that, you're busy in surgery, the patient might be compromised and you want to get it done as quickly as possible and you put the implant in. It's not quite as deep as you want it, but you sometimes compromise and you sort of say, I'll leave it like this because it's taking too long to get it right. So as a manufacturer, you've actually got to make stuff robust so that it can work even when things aren't done optimally. It would be wonderful if, everybody were absolutely top clinicians, but they're not. And, the ones that break, the ones that give you the nightmares are generally not done by the top clinicians. Mm-hmm. So you've got to make your product robust. And putting the machine surface on the top 3 millimeters is really part of that robustness. Where people got it wrong is that they made it too smooth. And the reason is that between when Bronnemark made those first implants, the grinding wheels for the tungsten carbide cutters had got to smaller grit. And that then made the cutters that people were cutting the surfaces too smooth. So 3i made that initial implant, and some of them would lose bone. And it was just that they hadn't got to that. Now, thinking back to that, in those days, we didn't have confocal laser microscopes that we now have that can do that. So as time goes on, you get better tools to be able to control what you're doing. And therefore, you can use that and you can now optimize. So we used to have our spec on the rough surfaces sort of between 1 and 2 microns. Well, now we're down to sort of the 2nd and 3rd decimal place because we can control it that much better. And we can measure and we can measure it. So did we make bad implants in the past? Well, they probably weren't as consistent as what you can do today. And that's the lovely thing about it, technology developing.
Yeah. So talk about just a little bit more philosophy here from a company standpoint. We've obviously heard that, you've got a very good handle and control over, doing things right. How do you get that through to the people that are, on your team who are talking to the doctors, to the clinician, and how do you look at what your company's doing and get that across that differentiates you from, say, your competitors?
Yeah. So I think the one thing is you've got to get people to buy into the philosophy of the company, and they've got to be passionate. We have people. The average tenure of service of people who work for us is over 10 years. When we do the 25-year awards, there are quite a number of people that come forward that have been there. So they're fully invested in the company, and we allow employees after a certain amount of time to actually buy shares in the company. So you get them totally invested in it. So and obviously it's fun to do these exciting things and work with really top clinicians. Everybody gets stimulated, and it's a case of, gosh, I can't let down Rolf Bettens in Germany, in Belgium. We've got to get this for him, and Philippe Kayet, and all guys all over the world that are sort of reliant on you coming up with the right stuff. So the engineers actually work directly with clinicians, and they go and yes, when I'm here, I love going to surgery and watching people do things, and whether they're using opposition products or not, you learn so much. So you've got to get into that. So I think the key is a full 360 view of what machining technology. So you go to machine shows, you've got to keep your finger on all aspects of it, and we don't really put people in boxes. We let them go and explore outside. So it's a little bit like the Microsoft sort of thing, people walking around and talking to each other, and not being too constrained, so that they can be innovative. So,
getting ready to say a culture of innovation.
That's right. And it sounds like you're having fun in addition, which I think is important.
Yeah. So if you're not having fun, it's not sustainable, because then you're going to look to wanting to get out and sell and go fishing.
That's right.
And Richard Lazara was the one who told me, he said, don't sell the company. We had a Warburg Pincus were onto us and were wanting to buy the company, and I met with Richard, and he just said, do you need the money? And I said, no. He said, then don't consider selling. It's much more fun to be doing what you're doing. And I immediately went and decided, well, that's what we're going to do. We have a lot of fun.
I tell you what, is if you're interested in knowing more about how you can take it really to the next level, and you're listening to this, the first thing that I would take from this is you've got to put people around you that are better than you. And Dr. Brandemark said that, John. He said, if you're bound to succeed if you surround yourself with people that are better than you. And I think that's what you've done, is you took advice from him before he even made the advice, or maybe you saw that. And it really has raised our level as we come to organizations like this and being around people that are better than us. Tell us what it means to come from South Africa as we close this show, to come to America, to come to the Academy of Osseointegration annual meeting. Why do you come here all the way from South Africa?
Well, this is the premier meeting of dental implants in the world. So I've always been coming. I've been a member for 30 years odd, or whenever the AO started. So I think it helps you rub shoulders with the people. You see people, you have stimulating conversations. So that's it. But absolutely, you've got to surround yourself with the right people. And if you do the right things, the right people tend to come along. So towards the end of P.I. Bronemark's life, he would phone me at least once a month, often once a week, and discuss what he was. Now, he was still in his latter years as innovative as could be. And we did development projects with him right until the last year of his life, which was the fun of it. So when you deal with those people, it just becomes more stimulating.
And that's what we've always said. That's why we do what we do, is because it's about putting yourself around passionate people. And that's why we come here as well. So
it's inspirational.
Thank you so much for being with us. We really appreciate your time.
Thank you.
It's been a lot of fun.
John and Wes, thank you very much. Wonderful being able to talk to you.
Thank you.
If you've been listening to this, I think, and you've hopefully gotten to some maybe things you've never even thought about before, about how manufacturing's changed and how it's affecting the way that we do things, and how the agility of a company can make a difference in your day-to-day clinical world. I think this is, again, why we come to this meeting, is because we have passionate people. So, Wes, it's been a lot of fun.
Love it. So I'm so happy that we're here, because we go to dinner and we're sitting there with a napkin a lot of times and drawing out the things and figuring out all the nitty gritties. And really, if you want to make a game changer move in your practice, it's about coming to these meetings. It's about meeting people like Graham Blackbeard and meeting the reps that are out there in the workforce and really trying to find out who the passionate people are that can make your clinical skills better for the patient, and that's the key. We're here for the patients, and that's what the Academy is all about. And I really appreciate the Academy having us here this weekend. And so for Graham, John, I'm Wes, and we are the Dental Guys.